Can you hear me? Yes. I always have to adjust these down because I'm so small. My name's Alison Green, and I work at Vertical Aerospace, and I'm delighted to be here with Sam Hill from Solvay for us to talk about the work we're doing in the urban air mobility market and composites. We go. So a little bit about Vertical Aerospace. We're a company based in Bristol that was founded in 2016 by a guy called Stephen Fitzpatrick, who has a real passion about clean energy and clean aviation. He started the company with only 6 engineers in 2016, and in 2018 they produced their first prototype, which is the first one you can see here, which I can't point to, but it's a little round one that looks a bit like a drone. And then in 2019 they flew their second prototype, which is the VX4, which is the second one that looks more like a helicopter. What we do is we make eVTOLs, which are electrical vertical takeoff and landing vehicles. The reason we do these is that urbanization means that there are more and more people living in the cities. You may have yourself found yourself sat in traffic a lot. These types of vehicles we see as a way of the market to solve the problem of some of the traffic jams that you see. So the vehicles themselves are capable of doing a vertical and also a conventional takeoff. They're fully battery powered, so they use clean energy, and they're 100 times safer than a helicopter. So we really feel that this is a gap in the market, and this will be the future of aviation. The company itself has got now about 300 employees in our Bristol facility, and 250 of those are engineers. So this is a timeline of what the company is looking at. So I've talked about the 2 test flights that we did with the 2 prototypes. And at the moment what we're doing is we're making a prototype of the VX4, which is our certification vehicle, which should be flying in the next few months. And we are making it at GKN's facility in Filton in Bristol. In the GTC. The prototype itself is fully carbon. There's a little bit of metallic, but it's mainly composite. And it's capable of taking 4 passengers and a pilot as well. So these aircraft will be piloted. Moving forward, we will build the prototype and do the test flights this year, and then we're looking for certification in the next few years. The certification we'll be looking for will be with the EASA and the CAA. So a lot of the work we've been doing with Solvay is to look at how we're going to qualify the materials in time. So this is the VX4. This is the aircraft that you will see flying around in the next few years. It's got 4 tilt rotors at the front, which are capable of the vertical and the conventional flying. And then at the rear, you can see it's got 4 scissor rotors. They're stowed during a conventional forward flight, but they are there purely for the vertical takeoff. The aircraft itself is capable of doing about 100 miles and taking 5 people, but one of those will be a pilot and their luggage as well. And the point of these are the short hops. So the intention is you'll take your commercial airliner from JFK in New York, then you'll fly to Heathrow and you'll get on one of these and it will take you to Canary Wharf. It will shorten the journey time from Heathrow to Canary Wharf from about an hour and a half to about 20 to 30 minutes. But the intent of them as well is it's not just for the super rich. We're looking and targeting around $1 per mile. So it really will be an affordable flight for everyone, similar to an Uber. It's the Uber of the future. We have got an order book, so we have sold a lot of these aircraft. We've sold about 1,350 to date, and we've sold them some really, really sort of great brands, so Virgin Atlantic and American Airlines have bought a lot, and then we also we have Avalon, who's one of our investors. They've managed to lease a lot of these aircraft to companies such as Bristow, AirAsia, Japan airlines. There's lots and lots of customers of this aircraft, and we have sold, I think our order book at the moment stands at $5.5 billion. This explains a little bit more about what the VX4 looks like, and also we're slightly different from our competitors. A lot of our competitors have looked at trying to make everything themselves. We at Vertical believe that the best way to make it work is to partner with the right partners, and I'm here with one of the partners today. We have Rolls-Royce, who are our partners looking at the electric propulsion unit. They're doing the motors. We're partnered with Honeywell, which are looking at flight control systems. Then we have partnered with two composite suppliers, so we have GKN and Leonardo's. GKN will be looking at the wing, Leonardo's will be looking at the fuselage, and then finally our composite material partner is Solvay, and this is who we will be talking together about what we're doing to develop the material. There's some key things when you're making eVTOLs, and I'm head of structures at Vertical, so I'm going to talk about the structural aspect of what we need to do here. So the challenges to this type of vehicle sit around weight, the loads, the costs, and the rate. The reality is we're looking at a lot of these aircraft well beyond the current commercial aircraft are made at maybe rate 60, 70 with a target of 100. We could be looking at doubling or tripling the need for these types of aircraft. So rate is very important. The aircraft itself is very, very sensitive to weight, so we really have to look at a lot of weight savings. And the biggest challenge that I have personally in structures is some of the weight is non-negotiable, so things like batteries just weigh a lot, and you can't change that. So everyone looks for weight savings in the structure. Then when I talk about loads, the problem with this is that we don't actually know anything. There's no data. So if you build a derivative of a single-aisle aircraft, there's lots of data, because they are basically the same thing. With these, there's nothing. It's a bit like a helicopter, a bit like an airline, a little bit like a small jet. There's lots of different things in there. So we have to create that data as soon as possible in order to certify, and that's quite a challenge. And then the last thing is the cost. We want this to be affordable for the general public. So if we build an aircraft that costs us $10 million to build, it's not going to be affordable. So there's a lot of challenges with that as well. So how are we meeting these challenges? There's a lot of work that we're doing to do this, because it is a very big task what we need to do. First of all, for the weight perspective, we are really going to have to fully utilize composite materials. We do a lot of I'm from a large OEM before I came to Vertical. We do a lot of what I would call black metal, where we just basically make composites, how we'd make a metallic part. I haven't got the luxury to do that at Vertical because weight is so critical. So we're really looking at steering fibres and putting fibres in the right areas. So we look at fibre placement technologies. There's also a lot of work that we're interested in with 3D printing, especially thermoplastics, thermosets. And then we're very, very interested in thermoplastic development. The other thing that we are looking at is how we really utilize multifunctional structures as well. So we are looking at things like battery casings that are also capable of crash cases. Because if we can really, really make use of multifunctional structure, it means that we actually save ourselves a lot of time, a lot of weight in the future. Then I've talked a lot about cost, so we do have to look at low-cost materials. We're really looking with GKN and Leonardo's at how we make it more automated. The difference is, again, is the design teams are already starting with, we have to make an automated part. And they're really using a different mentality to design this. In the more traditional ways at aerospace, we would do a design in the design office, chuck it at manufacturing and say, here, just do it. We're not doing that with this. We're heavily involved with our manufacturers to try to make a real design for manufacture. We also are very interested in sustainability. We're a green company. We don't want these to be put into landfill later on. So we are looking with our partners like Solvay at how we can recycle, but also our partners like GKN and Leonardo's about how they can use renewable energy sources, how they recycle. Both companies have got very, very strong recycling targets they go for. Then the rate, so I've mentioned before that we are looking at designing this differently. We are looking at real design for manufacture. We have a lot of integrated teams. We look at our suppliers as partners and we're in it together. We are really working a lot to say, well, what do we need for the different departments? So the collaboration is very, very key to what we're doing. And then finally, when we talk about loads, and I've left this to last because this is what Sam's going to talk a little bit more about, we have to look at bespoke materials that are specific for what we are going to utilise them for. And we are looking at developing a lot of analysis techniques as well for this type of aircraft. The materials challenge is one of the biggest things we have. There's a lot of work that we need to do to get it certified, to get it qualified, and that's really, really important. So I think I'm going to hand over to Sam, and he's going to talk a bit more about some of the work we're doing to solve that issue.
Thank you, Alison. Good morning, everybody. My name's Sam Hill, and I'm the Urban Air Mobility Market Manager for Solvay. And I'm going to be talking to you today around the partnership approach that we have with Vertical. And this partnership is really built around a set of shared values and trust, with the main objective being to develop innovative solutions for zero-emission flight. So the companies come together. They bring a lot individually. Alison's just talked around the world-class urban air mobility design that Vertical have and the VX4, battery technology, this distributed electric propulsion technology, which is really important, and a lot more. From a Solvay perspective, we have 40 years of heritage of delivering advanced materials into the aerospace industry. As well as that, we have experience and knowledge around developing solutions for high-rate manufacturing industries like the automotive industry. At the center of our partnership, which is really important, are two main areas. One around material and process selection, and this is really where we work with Vertical and the partners in order to understand the key requirements. So that from a manufacturing perspective, a cost perspective, a rate perspective, and a performance perspective. And we're utilizing Solvay's applications engineering model in order to select the right material and process for the right application. Secondly, there's a focus around stress analysis and qualification. So ensuring that Solvay's materials have data to support the Vertical design and stress engineers so they can use our materials for the very get-go when they're starting to utilize the materials within their design. The other aspect is having qualification capability, aerospace qualification capability, and a suite of materials that are NCAP qualified. So this allows to reduce the development time and cost. So we're working with Vertical to meet the means of compliance that they've set out with the certification authorities, because certifying aircraft like this is a very rigorous process. So the partnership is really built around a strong technical foundation. So we're working collaboratively together in a transparent environment. So we call this an integrated project team. So we're co-located at the GTC at GKN. So we're working across multiple functions from a Vertical perspective, so working with the design and stress team, program management team to look at schedules, looking at the critical path to make sure that we're developing solutions to meet the entry into service, materials and process, certification team, and also the structures team. From a Solvay perspective, there are three main technical departments that are interacting with Vertical. One is around our applications engineering and product development teams. So this is the team that really looks at innovating new materials, bespoke solutions, and processes for Vertical. We have thermoplastic and thermoset application centers. These are co-located in the UK and Brussels, and this gives us the ability to validate our material performance in-house before we deliver to Vertical. And we also have capability of manufacturing small prototypes. And then the trade study analysis. This is where we look at total cost of ownership. Typically, this is done in a collaborative manner with our partners, so with GKN, Leonardo, and Vertical, really to understand the economics and the rate capability of the solutions. Secondly, our customer engineering team. So this is really the day-to-day technical support that we provide our customers. This is the voice of the customer. So these guys understand the requirements, so they're feeding them back into our internal teams within Solvay. They validate material and process windows, and they provide on-site support on a daily basis when Vertical and the partners are utilizing our materials to ensure that they're using them in the right manner, in the right processes. And lastly, around our test and qualification team. So this team really here to screen materials from a performance perspective, have experience and coordination of aerospace qualification processes, supporting Vertical with material specification generation, and we have a suite of NCAMP qualified products as well, which this team coordinates, and the equivalency programs that are required for everybody in the supply chain who are utilizing our materials. And this is all done through our NCAMP approved labs, and we have AIR and AER approved from NCAMP, both in the US and in Europe. So when we look across the VX4, Solvay are really contributing to all of the major components. So airframe from a primary structure and a secondary structure, the propellers, battery enclosures. So you may have heard Mark Wright from Solvay discuss yesterday around Solvay's development in battery structures. We're very present in this arena. Interior products, e-motors and brackets, whether they are structural brackets or non-structural brackets for interiors or electrical systems. And one of the key value propositions of Solvay is the diversity of our portfolio. So as you can see, we offer a full range of material systems, so really a one-stop shop from an eVTOL supply perspective. So we have liquid molding materials for RTM processing and infusion, thermoplastic prepregs, thermoset prepregs, whether they be VBO capable, autoclave cure capable, or press cure capable for high rate, and then a full range of advanced adhesives solution from paste adhesives and film adhesives and surfacing films, as well as our specialty polymer range of technologies which goes into injection molding processes. So one of the very key focuses in terms of the partnership with Vertical is the ability to work together and translate the structural design drivers to material properties so that we're able to down select the right materials to provide light weighting, which is particularly critical within this market segment. So at a very top level here, we've given some examples. We've coupled the wings, pylons, and fuselage. And what we can see is stiffness is a key design driver. So establishing materials that are going to meet the stiffness and bearing bypass requirements. We don't just look at structural performance, though. We're looking at the process elements. So the geometry of the parts, the size of the parts. So, for example, large acreage parts like wing skins, fuselage skins, and how we manufacture those. And also high aspect ratio parts like fuselage frames, like stringer stiffened elements, which typically have very complex geometries, and we require a high level of automation to meet the projected rates that Vertical have. Propellers are slightly different in terms of the design requirements. Impact is absolutely critical, as well as stiffness. But one of the process requirements here is really around rates. So you look at the number of propeller blades on the VX4, and you consider the build rates of up to 3,000 aircraft per year, you quickly start understanding the rate challenge that we have. So making sure that we have the right materials, but also the right product forms for the complex geometry of the rotor blades. And then from the airframe perspective, really looking at how we bring these components together, whether it be in a structural bonding mode or a mechanical fastening mode, and making sure that we have the right multifunctionality, so lightning strike protection, EMI protection as well. So when we look at the market cycle, we really see this in three different phases. The first phase being the prototype phase. And we supported Vertical through the entire prototype phase. And as Alison mentioned, we're nearing first flight in the next few months. So some of the key design drivers or drivers for prototyping, one around reactive supplies. So the ability to supply material very quickly into this prototype in order to shorten as much as possible the development timeline. Design data is critical, so having accompanied data with our products to allow Vertical to use the products from the very outset. Performance is key. We spoke around light weighting. And flexible processing is absolutely critical to allow everybody within the supply chain to utilize the materials, whether they have autoclaves, ovens, or other assets. The second phase of this is really around the certification phase and early initial production. So reactive supply is also a critical driver, but having a longevity in the supply, so an established supply chain, is critical. Tailoring the performance, so learning from what we know about the prototype, evolving the materials, the processes for further lightweighting and performance enhancements. NCAMP qualified, I spoke around that in order to shorten the development time, the qualification time, and also the cost associated with that. And at the bottom there, complete portfolio solution is absolutely critical from what we see. So the fact that we're not just providing structural materials, we're looking at the complete solution. So adhesives, surfacing films, materials that are fully compatible with each other, and ensuring that we have the right data to demonstrate to Vertical and its world-class partners in terms of the way these materials work together. So in terms of some of the solutions that we're offering, firstly around our next generation thermoset toughened pre-pregs, which are automation capable, so AFP capable, as well as our new range of aeropaste materials, which are paste adhesives that can be used in automated processes for structural bonding. And with this, we need to keep an eye on the future, so future rate capability. So we're looking at thermoplastic technologies, both for stamp forming, so with our APC materials, injection molding, as well as thermoset materials, and putting these into presses so that we can manufacture high-quality aerospace parts in a low takt time. And structural bonding is absolutely critical if we look at trying to lightweight from an assembly perspective, take as many fasteners out as possible, and looking at robust solutions to enable this. And we have our fuse ply technology, which is an active surface ply technology. So Solvay is really excited about working with Vertical on this revolutionary project. And I'm just going to leave you here with a video from Alison.
So I hope this works. I'll pull it down. So this is the VX4. If you'd like to look at it a little bit more closely, we do have a model of it on the Solvay stand, so please come up there and meet us and we'll talk you around it. So we have got 2 minutes for questions, if anyone's got any questions. Okay. Thank you, everyone. Which way do we go?